This would be another example for a difference of squares. X squared minus 6x plus 9 minus y to the fourth power. If you notice again, it looks like I can factor first a portion of my expression into a perfect square trinomial or a perfect square binomial, and then the other one is just a value square. This looks like this is x squared, this looks like this is 3 squared, and the middle value it's 2 times x times 3. I'm going to factor this portion of my expression as x minus 3 squared, just like we did on the previous example, in part A of this example, minus this y to the fourth power can be factored as y squared squared. Now that I have my difference of squares in the form something squared minus something squared, this would be, in this particular formula, this would be my x and this would be my y. All I have to do is just rewrite it using this x plus y times x minus y. X minus 3 plus y squared times x minus 3 minus y squared. There's nothing else I can combine. This would be the factor form for this polynomial. This is the coffee example. I would like you to pause this video here and attempt to do it. But I will continue. In this example right here, we can already see that our first portion, or the first term, is already a binomial squared. So I don't have to focus or use some of my time factoring it because it's already in factor form. But I do need to rewrite my second term. It looks like 4c squared can be 2c squared. And I'm just going to rewrite the first term just so we can have it. Now I have two terms squared subtracted, or one subtracted from the other. If I use this formula right here, I will rewrite this as a plus 2b plus 2c times a plus 2b minus 2c. And this is my factor form. Here would be the two I do by myself examples. And I would like you to pause it and attempt them, but let me show you the answer. 256k to the fourth power minus 625m to the fourth power. Both of these can be rewritten as 16k squared minus 25m squared. And I didn't mention it on the previous example, but this rewriting as 4, the exponent 4 as 2 to the power of 2, it's by the property of exponents. A power of a power, you multiply. But if you need more help with this particular section right here, this is because of a property of exponents. And now that I have it as a difference of squares, this will be my x, this will be my y, and my answer for this polynomial, 256k to the fourth minus 625m to the fourth power, can be factored as 16k squared minus 25m squared times 16k squared plus 25m squared. It looks like I can keep on factoring because this looks like another difference of squares. My first term can be rewritten as 4k squared minus 5m squared. There's not a formula for a sum of squares, so we cannot factor out the second term. And now the two factors for the first term will be 4k plus 5m times 4k minus 5m times this one. I'm just going to rewrite it. 16k squared plus 25m squared. In this case, I factor until I cannot longer keep factoring. This is the factor form for the polynomial. In the very last example, it looks very simple. I can rewrite this as 2m squared minus 3 squared. So 4m squared minus 9 is going to be factored as 2m plus 3, 2m minus 3. And before I forget, I know I switched them over here. I put the minus and the plus on the first example, but the order of the factors when you're multiplying, it doesn't matter. I know the formula shows x plus y first and then x minus y, but when you're multiplying 2 times 3 and 3 times 2, gives you the same result. Same with addition.